we get the same value of f, get the same value, which is f minus x equal to fx. For odd,
f negative x equal to negative fx.
for odd, f minus x equal to minus fx. Symmetrical, what about symmetrical? For the case of even, what is this kind of symmetrical?
Symmetry about what exists.
Symmetry about what exists. For case even, for case odd,
Symmetry about origin.
symmetry about the origin. And for the case of neither even nor odd, symmetry about what?
No symmetry.
No symmetry. Right. That's even odd and neither even nor odd function. Now we're going to look at the graph of the functions. So when we say about graph of the function, shape of the graph of the functions depends on the function. We have several types of functions. A linear functions, which the graph of linear function is straight line. We have also square functions. A shape of the graph of a quadratic function, like either open up or open down, like this. Open down or open up. Down or open up for case of quadratic function. We may have also constant function, constant throughout, always constant. We may have cubic functions, the shape of the graph of the cubic function. We may have the square root of function. This is the shape of the graph of the square root of function. We talk about shape. And from the shape, we have to find what's supposed to be all the points there. Only we want to know the shape of the function, the shape of the graph of that function. And apart from that, we have one kind of functions, we call it piecewise defined function. Piecewise defined function, meaning that that function will be defined by more than one. More than one. Normally, we look at the functions before, all the functions before determined by only one. Determined by only one. But for this case, determined by three. Or maybe, or perhaps, determined by two. Depends. Depends on the case of piecewise defined function. Sometimes defined by three, sometimes defined by two, sometimes defined by four. Depends. Same like inequality. Remember, for the case of inequality, for sign diagram, we have plus, minus, which one we choose? We choose plus or we choose minus. Not always when we say choose plus, not always plus. We have to look why plus we choose. Why plus we choose when we talk about inequality? Why we choose plus? Why we choose plus?
Greater than 0.
Greater than 0. For the case of we choose minus, why we choose minus?
Less than 0.
Less than 0. So, same like this. Same like when we talk about piecewise defined function. So, do not want to hear that one person who replied to me about why she get low mark in the examination, in the test. She said that the examples you given different from quiz or test questions. Yes. I say yes, because maybe examples you look today, 3. Later, maybe I don't know. Later in the examinations, they look for. Then you say, oh, always telling me about, always say that three, but why now 4? So does not matter. 3 or 4 or 2 does not matter. Important that you know this. Right. Okay. Imagine that this function, which is we call piecewise defined function, defined by this. And this function defined by this 3, depends on the value of x. For the case of x less than 1, this is the function we refer. For the case of x between less than -1, less than -1, we refer to this. For the case of x is between -1 and 2, we refer to this function. For the case of x is greater than 2, we refer to this function. Right. Now, for the case x is less than -1, when we want to sketch the graph, this is x-axis. This is y-axis. Now, for the case of x less than -1, x then less than -1, meaning that on left of -1. Because we're talking about this is, imagine that this is number line. Number line must start from very small number, then become bigger, and bigger. Now, case of less than -1, this is the function. The function of 1 minus 2x. So 1 minus 2x, we say this is what function? What function?
Linear.
Linear function, so it's going to be straight line, right? Why like this? Why like this? Why like this? Why? Why not like this? Why must be like this? Why? You may ask, why must be like this? Why not go to this, like this, or the shape like this? Why go to this, not this? Why? Why? Why the shape? If you look at the shape, we talk about a shape now. Shape is like this. But why? The important is why.
Because if we substitute the x -2 or -3, we get a positive number of y.
Yes. We substitute, right? Yes. But before we substitute, for example, if we look, we know that this is a shape. Why? How do we know?
Gradient is negative. The gradient is negative value.
Because negative. Remember that this is, we can rewrite as minus 2x plus 1. Same. This is represent what? Represent what? And minus 2 here. Represent what?
Gradient.
Gradient. M. When gradient is negative, so the shape of the function supposed to be like this instead of this. So this is a shape. when we're talking about shape. And we can find the value here, right? When x is minus 2, what value of y by substituting? But now we want to shape like this. And why we have arrow here? Why we have arrow?
From -1.
Because it's come from -1. And why we have a hole here? Why do we have a hole there?
-1 is not included.
Not included. And why we need to stop here? Why? Suddenly stop. Why not this line go straight here? Why? Why? In fact, this is line straight here, but we have to stop there. Why? Why we need to stop?
From -1.
We need to stop because part given to this function only for x less than -1. When come to x is -1, stop. Even though this straight line can be more straight line. This is straight line. We go straight. But the rest, they have to rub. We have to draw just up until -1. Right. And now we go to the case for x is from -1 to 2. From -1 to 2. Which means that from here to here. What is the shape of the graph? What is the function? We refer to this function.
Quadratic.
So the graph we're going to have is quadratic graph. So either open up, this is open up or open down. So which one is open up, open down?
Open down.
Why open down?
Negative x.
Negative.
Because negative. Go back to the quadratic. Because of the negative, it's up and down. Right. And what's supposed to be the value here?
P.
The value here, there.
P.
B. We should have B here, right? Remember that our function is a function of 3 minus x squared, this one. Or this one can be written as minus x squared plus 3. Same. It's same. Only that the way we write it is different, but same. So open quadratic, this is quadratic and will be open down. Yes, correct, because of negative here. And what's supposed to be the number here? Number 3. Remember that what's supposed to be there? We call it vertex, the most end. Either the most end in up or the most end down for the case of up and down. For the case of up and up, go down. But we in this case, and what is the value here? 3. So this type of graph is graph like this, right? Right. But remember that space given to this graph only from -1 to 2. So this one cannot. We have to run. And after 2 cannot. We have to run as well. So the graph only here. Only here. And where is the place supposed to be here? Where the place of supposed to be crossings of x-axis. This is what we call x-axis. This is y-axis. What is the place of crossings of x-axis? How to get the place of crossing of x-axis? Y equal to 0. When y equal to 0, what the value of x we got? Now, what the value of x we have when y equal to 0?
Square root of 3 here.
Square root of 3. Therefore, the value here will be square root of 3 and another one minus square root of 3. But for minus square root of 3, we don't need to write because more than -1. So it's start from here. Stop at here. Must be stop. If don't want to stop, must be stop. When times come. So what they call it? What the duration for you given from when you come to stop. Like the systems in the United States for informations. One president of the United States can only be in the office at most 8 years. That's the systems in the United States. After 4 years in the office, will be tested whether people still want or not. They have to make the elections and then see. If want, they can continue. He or she can be continued, but so far don't have she, right? All he, right? And after another 4 years, test again, and for another 4 years, he cannot be. He have to go out from the office. For instance, if you look at the current president of the United States, right? The previous president, Donald Trump, ran the country for 4 years, test. I think last year test. Test, and what the outcome of the test? People don't want. After don't want, so the new people come. And this, if he win again, but he lost last time. If he win again and he in the office, after 4 years in the office again, he must go out. Testing again, but we need and want another people. Same like this. You have to remember that your tenure is up until this. When you come to here, go. So when up the gates, right, and go to, so that this graph will go counter 2, stop. And is it include or exclude? Include or exclude? Exclude. Why exclude? Because this. Then, when x is greater than 2, we start a new phase, new chapter of life. We refer to this function. This function is square root function. This shape. Right. However, right, this is the function of fx equal to square root of x. This is shape, right? You get it? This shape of the square root function. In our case now, we want the function of square root of x plus 1, x minus 1. X minus 1. Different. This is x. This is x minus 1. It's going to be different. So, when x only, the place of the starting is 0. There. Start from here, from 0, right? Go up, right? But for the case, this one, start from where?
-1.
Not -1, plus 1. Because we make whatever inside this equal to 0. Like this. We make equal to 0. Yes, x is 0. When x minus 1 we make equal to 0, x is 1. So start from here. In fact, start from 1. Like this. And where are we going to stop? We don't know how to stop. Where is going to stop? Arrow. But the space given or the region given to us only more than 2, which means that we have to rub here. We have to rub here. And we have to start from here. Okay. Including or excluding?
Include.
Include. Bold is include. Include. So this is the shape of the graph for our piecewise defined function. Right, remember that when our piecewise defined function consists of 3 functions, we're going to have 3 different graphs, 3 shapes, 3 different shapes of the graph. And shapes of the graph where supposed to be changed the shape, look at the value here, because from -1 to 2, we only have -1 and 2. You get it? Right? And next, after we draw, we get the shape of the graph. Next is state the domain and also the range of the function fx. Right. How we know the domain for certain function graphically? How do we know? How do we know? Graphically. Remember that when we studied domain of the functions last week, how do we know that? From graph, how do we know the domain of the function? But how do we know the domain of this function?
The value in x-axis.
Sorry?
The value in
x-axis. When we look at the x-axis, what we're going to have? Yes, we look at the x-axis. So what we can say about the domain? Domain of fx equal to what? We look at x-axis.
-1.
-1. What happened to this? Less than -1.
-infinity.
Negative infinity. Because also this one we have to consider. This is a function as well. And where we're going to stop, right? Where? Stop. Stop where, right? When we look at x-axis.
-1.
-1. You look at the x-axis, right? Look at the x-axis. You just stop at -1. You just stop at -1. We talk about function. And when we talk about function, it consists of three different definitions. When stop at -1, only this definition. And this definition also defines the function. So what? Two. Why stop at 2? Stop here. You mean? If stop at 2, we just stop here. We forget about this. That means to stop. And that means to stop at 2. Is that mean to stop?
Negative infinity to infinity.
Negative infinity to infinity. We do not need to stop because stop covered by this. Hole covered by bull. As you look at the mountains, as I said to you, I said to people to understand this. If you look at the mountains, say this mountain. Then behind these mountains, we have another mountain. Then behind this mountain, we have another mountain. When we look from far away, we have all the mountains. But when we look at the shot, between these two mountains, maybe they have a gap. Like this. We have a gap, but we look at the far. We imagine that we have a look at the far, so it goes straight. Right. Oh, any problems? Any unclear? Why from minus infinity to infinity? You may ask why minus from minus infinity. You can see. Imagine that come from come from minus infinity. Then must be stop here. Yes, stop here, but cover by this. Continue. Must be stop, but cover by this. Why can be covered? Because bull. If not bold, cannot cover. Bold. But definitely it's going to be one bold and one whole. We don't have two of them whole. Two of them bold. No. And it's going to look smooth from minus infinity to infinity. Okay, right. Okay, that's domain. Range. Range of fx. Range. We refer to what for the range?
Y-axis.
Y-axis. So what can we say when we look at the y-axis?
Negative infinity to 2.
Negative infinity to 2. Why negative infinity to 2? We look at the y-axis. Why? No more x. Right. When we say from negative infinity to 2, is that we have graph. When we say about domain, we look from down to up. Because we talk about y-axis. Domain, we look x-axis. Range, we look y-axis. When we look domain, we look from left to right. Now down to up. If you say negative infinity to 2, then we have graph. Here. We don't have graph. We don't have graph. Unlike here, we have graph. Yes, we have graph. Arrow here, meaning that graph goes on. Now, we don't have graph. We don't have a graph at all. You understand?
-1 to infinity.
-1. Why -1? Why -1? Because when we look, we go out, we don't see that we don't have graph, we don't have graph, we don't have graph, we don't have graph. Suddenly here we have graph. Where our graph start? -1. How do we know this is -1? How do we know this is -1?
From the quadratic equation.
We just because this is the graph of the quadratic. And we substitute x with 2. What happened to the y? Y is -1. So -1. We start at -1. But we have to we have to know, we have to determine whether it is include or exclude.
Exclude.
Include or exclude?
Exclude.
Exclude. The symbol here is exclude. And we stop at where? Is that we stop?
Infinity.
Infinity. Ah. Remember, domain X axis, left, right. Range Y axis, down, up. Left, right, down, up. Left, right, down, up. Ah.
Sir. Sir.
Yes?
Why -1 is exclude?
Because the sign here, you look at the sign. When we reach 2 or -1 here for Y, the sign here is whole. Right? Whole meaning that exclude. Whole, this is a whole. Whole here. Whole. Ah. Whole meaning that exclude.
Thank you, sir.
Ah. Okay. Whole meaning that exclude. Okay. The next one. After we can find the domain, we can find the range. Evaluate f -3. Right? F -3. Evaluate meaning that you need to find the value. Now, what is our x? What is our x?
-3.
This is our x. This is a function fs. Whatever inside the bracket is x. X is -3. Where is -3 now? You look. Where? Where is -3?
Less than -1.
Huh?
Less
The
than
first one. So x is situated here. So we refer to which function? This 1 minus 2x. Therefore, 1 minus 2 minus 3. Which is this is equal, right? 1 minus 2 times minus 3, which is
7.
7. So that's the value of evaluate of f minus 3 is equal to 7. When we want to evaluate the function, we look at the value of x here. What value of x? And we have to select among those which one x appear. Suddenly, when we look here, x appear here. When x appear here, we refer to this function. But when x appear in the second one, we refer to the second function. When x appear in the third, we refer to the third function. It's like this. Let's say f3, for example. We refer to here. F minus 1. Let's say f minus 1. F minus 1. Let's say. We refer to each function.
Quadratic.
The second one, 3 minus minus 1 square, which is 2. Right. Commonly, common this type of this kind of the questions. Common whether the questions in your test or questions in the end of semester examinations. So remember, always remember what I said. Domain, we look at the x. Range, we look at the y. And the functions here will be defined by more than one. Depends on the region given to us. Right. Right. Take a break for a while and come back at 9 o'clock. Okay. Right. Welcome back. Welcome back. Okay. When we talk about piecewise defined function, one kind of the questions is given functions and sketch graph. Like what we saw in the first half of the sessions today. Given functions, we sketch the graph. And from the graph, we determine domain and range. And also we can evaluate of a certain value of x. Unlike that, we have one type of questions that given a graph, given a graph, it's opposite before. Given a graph, from the graph, we have to define what is fx. We have to determine domain and range of fx, and we have to evaluate f11. Similar like before, all the questions here is similar, except that the first one. If you remember that the first half, we get the function fx and we sketch the graph. But now graph is given, we need to find fx. What's supposed to be our fx? Fx will be defined, will be determined by what? If we look at that, how many graphs that we have? How many graphs that we have?
Two.
Two.
Two graphs, therefore we define by two, so to write 1, 2. And if we look at the value of x is from where to where? From where to where?
-5 to infinity.
The first graph is from -5,
Or
including or
to-
excluding?
Including
Until
2.
And what is the graph here?
Y equals to 2.
Equal to, what is the graph? What is the graph?
Linear.
Linear, but to more precisely.
Y equals to 2.
So what can we say? What can we say? What can more precisely we say? Yes, it's y equal to 2, yeah. But what can we say about the graph? What the name of the graph? What can we say? What can we write in terms of fx? Fx equal to what?
Zero gradient.
X equals to 2.
Fx equal to
2.
2. Ah. And then we have another graph here. Now, start from 2, including a knot.
Yes.
Now, and finish at
Infinity.
infinity. Or we write like this, or same. Same meaning. Only the way we write is different, but same meaning. X, it must be greater than or equal to 2. Or we write like this. Nah, this is same. Normally, for the case, the last one, we write like this. But if you write like the previous one, it's okay. Nothing wrong. So remember that we have several things that the way we write it's different. It's represent the same thing. Right. So what is the function?
Negative 3x plus 2.
Minus 3x.
Minus 3x plus 2.
Why minus 3x?
If you say 3x plus 2.
If you say 3x plus 2, right? Try to substitute. When x is 2, what is the value of y? 1. 3 times 2 plus 2. Is that 1? Is that 1? When x is 2, y is 1. When 3x plus 2, you try to substitute. X is 2. Is that 1? No. It is not 1. Therefore, this is not our graph. And definitely not this one. Definitely, if we look, definitely because our m slope is positive. How can we get this graph? This graph only for the case of slope is negative. You remember that the previous one, the first half, right? Why I say that the graph is negative. So this must be negative. But here, what kind of graph?
Linear.
Yes, linear. What graph? What is the graph?
Negative 2 over 3x plus 2.
Negative 2 over 3x plus 2. Okay. We try to substitute x with 2. As you see that. Minus 2 over 3 times 2 plus 2. It's because 0. Not 1. Must be 1. So this is wrong as well.
Fx equals to negative x plus 3.
Negative x plus 3.
Plus 3.
Negative x plus 3. Right. We try to substitute x with 2. Minus 2 plus 3. Negative 1. Correct. Correct. Therefore, this is our function. Yes, minus x plus 3 because you try to substitute. Right. Or if you want to know, it's like this. linear. Luckily, this is linear. If not linear, difficult, right? If linear. Linear, when x is 3, y is 0. So you see when fx or y is 0. 0 to get 3, x plus 3, right? So x must be plus 3 when x is 3, right? When y is 0, x is 3. So you substitute x with 3. You get what you say, substitute what the value of x which make 0 here. Definitely minus 3. When you substitute minus 3 plus 3 make it 0, right? So because this is what they call the slope must be negative, so must be negative. We put negative for x. So when you substitute 3, so minus 3 plus 3 is 0. So you get the define of fx. This is one kind of the questions. Apart from the question, if you look at the first one, given function, draw graph. And now given graph, draw function. And y here include bull. Exclude, because we look whole. Include until infinity. Then determine the domain. Domain of fx. Remember that domain, we look at what?
X exists.
X exists. So what is the domain? If you look here.
-5 until infinity.
-5 is the include.
Yes.
Include until infinity. Because even though we have to stop here, but it's covered by this. Include. Range. Range.
Negative infinity to 2.
Minus infinity to 2.
Sorry, 3.
Is it a
2.
2?
2.
Is it a 2? remember that range, we look at the y-axis. We will start from behind. Start from bottom. Right. Yes, negative infinity. Because this graph it goes on the negative infinity. Goes. Then. You have to stop, right? If you say until 2, how can we go to 2? Because we have a gap there. Right. We have to stop here. Stop. Not until 2. We have to stop here, right? Stop.
Negative infinity to 1, 1 to 2.
Negative infinity to 1, right? Is that include?
Include, yes.
Include. Union with? Union with what? Union with? Okay. Here.
2.
2 only. Or the only 2. Because the only 2 and we have no what we call intervals of 2, just 2. Union with just 2. Because not meaning that from 2 to infinity, not meaning that the only 2 with the sign of set. This set. This is not set. If you look at the case of like this, it's only 2, and we have to remember that always when we look, we find the range of the function, we try to look from behind, from bottom, goes up until when? Is that we can go straight? No, because we have to stop here. But even though we stop, we do not stop for good. We stop for a while because we still have more to go. But when we want to start here with 2, well, we want to go up. No, we cannot go anymore because this graph is graph. This graph that only 2 for y. Horizontal graph. Therefore, only 2 and only. No more than that. And we do not know. We do know. It's not that 2 to until infinity. No, only 2. This is rare happen, but might happen. Rare happen, might happen. Right. Then the last one is to evaluate F11. First of all, before we go further, we have to look at the value of x here. What is the value of x?
11.
11. You look where 11 located. This one. We refer to this. Therefore, F11 is minus 11 plus 3, which is minus 8. Which is minus 8. You can see the difference between this and the previous one. Now, the main difference here is graph given, find function. The previous one, function given, sketch graph. to find the domain and range. I hope that no problems of getting that. Only problems of getting the function, I think. Or for the case of sketching the graph, maybe problem of sketch the graph. Once we can sketch or we manage to sketch the graph, we can find domain and range. Be careful this type of questions, because if you sketch the graph wrongly, I think your domain and also your range will be wrong. So make sure that correct your graph. I think this one is no problems. To remind you again that our quiz one will be a week from today, 9th of September, 8 o'clock in the night. And our quiz one will cover chapter 1. Yeah. Remember those three parts of chapter 1. Another type, we go back to the type of the questions in the first one. Given the function, sketch. We have x and y. X minus 1 and absolute value of x less than 1 by using properties of absolute value. What does it mean by that? What does it mean by that? Absolute value of x less than 1 by using properties of absolute value inequality.
All the x value will be positive.
It does not mean that. Properties of absolute value of inequality. Have you got the books now? Or you still don't have a book? I ask that because the process of books, I do not know. Because somebody else in charge for the books that you need to give email, I don't know. That's what I don't know. So you have your book now? Not yet. Not yet. Is that, I think one talk last night, right? Have you joined the talk about book that I gave you the talk? Right. I think one talk last night. Right. So now this does mean that x is located between -1 and 1. Now, meaning of that, if you read again of the properties of absolute value of inequality, it does mean that x is located between -1 and 1. So -1 and next is 1. Okay. Now look at the value when x is less than -1. The value is -2. -2 is here. Fx is -2. -2 is here. So when x is -1 or equal to -1, graph will be always -2 until infinity, always -2. And is that here is it including or excluding?
Include, sir.
Include. Include. Right. From -1 to 1. Greater than equal, sorry, greater than equal. Here, from the second one is from -1 to 1, from here to here. So, what is the function? What is the function? What is the function? What is the function from -1 to 1? The function from -1 to 1? From -1 to 1? Yeah. Okay, from -1 to 1. From -1 to 1, what is the function?
Cubic function.
Cubic function. So, cubic function for x is equal to 1, y is the equal to y. 1. So cubic function like this. X equal to -1, so y is equal to -1. Cubic function. Cubic function. The shape here, right? The shape. The shape of the cubic function. We refer to this cubic function. And how do we know this apart from the shape? If you do not know the shape, you substitute the value of x. What the value of fx you get? Or if you know the shape, definitely this shape. But we still need to know the place here and the place here. So, is that including or not here? Including or not?
Not.
No. Because now we refer to this is meaning that not including. Now we refer to the second, not including, and also not including here. Not including. But including here. Okay. When x is greater than 1, this function What is this function? What is this function? The name of this function?
Quadratic.
Quadratic. So when we talk about quadratic, it either goes open up or open down. Now, only there's two. Which one? Either open up or open down?
Up.
Up. This one. Why you say open up?
Positive.
Because
Positive.
Power of 2 is
X
positive.
is power positive. So open up, and remember that for the case of X, Y, right? It's like this, right? This is for the case of the function is X squared. But we now X minus 2 squared. X minus 2 squared. So where we need to start? Where's supposed to be our n? No, the most bottom. This case, the most bottom is located here. But for our case, because our case now is a case of x minus 2 squared, where is supposed to be?
2, sir.
2. 2. Therefore, it's going to be like this. This is the function of x minus 2 squared. And now, add 2 here. Is that like this? It's like this. Right. Fine. You get it? Is that correct? Is that correct?
No, sir.
Why? Why not correct?
Because supposed to be starting from 1.
Not correct because starting from 1. Meaning that we have to remove here. We have to remove here and start from here. And the place that we start with that include or exclude? Include or exclude? Include. Therefore, whole here become include. Then, where we stop here? Where we stop? Where we are going to stop? Infinity. Now we sketch the graph. We managed to sketch the graph. The first part is to sketch the graph. Next, determine domain and range. As I said before, that if your graph is wrong, definitely domain may be wrong, and range may be also wrong. And now we look domain domain of the function fx. What is the domain of the function fx?
Negative infinity to infinity.
Minus infinity and finish at infinity. Because domain left to right. Range range.
-2 until infinity.
-2 until infinity.
-2 union with -1 to infinity.
-2. Sol, only -2. You see here. We come from behind. We come from bottom. You see -2. And then we cannot go because we have a gap. So -2 only, but we still have graph. So must be union. Union with what? From -1 we start again. Is that including or excluding?
Including.
Excluding. You see the time, the sign of whole here. Whole meaning excluding. And then
Infinity.
until infinity. -2. It's Sol -2. This is only -2. This is same like the previous example, right? We have only one number there. Represented by set of consists of only number -2. But we did not stop at -2 only. We have to go further. So we have to restart again when y is -1. And where are we going to stop? We don't know where stop. We say that's infinity. Right. Understands about of the concept of domain and range by determine domain and range by looking at the graph. Right. You want that here bold. Here whole. At the beginning whole, but become bold. Because of this, the sign. Whole bold here, important to determine here. Including or excluding. The last one determine x if fx is 1. So we look at the graph. Fx is 1 here. What the value of x there? What the value of x?
1, sir.
1. So x is 1. When fx is 1. Now, it's a little bit different from the previous one. The previous one, if you want to find a value, not to find the value, look at the graph. When fx is 1, What the value of x? 1. Sometimes we may have two values of x. And we have a case like that. Right. So I'll stop here. So tonight you look back again at this of especially piecewise the shape of another function as well, but especially to sketch the piecewise defined function, definitely we need to know the shape of this, like cubic function, square function, or quadratic function. Right. So inshallah we'll see you back on Monday next week. Monday 10 o'clock. Right. With that, I close the sessions today with Tasbih Kifara and Surah Al-Asr.